SpaceX has made a name for itself with its remarkable ability to land rockets on drone ships, a feat they've perfected with the Falcon 9. However, many wonder why they aren't using this method for their mighty Starship. While many people believe that landing on the Chopsticks, the massive mechanical arms used to catch rockets, is the only way for Starship, they're mistaken. SpaceX has always had an audacious vision of landing Starship right in the middle of the ocean. So, how exactly is Starship going to land on drone ships, and what does SpaceX need to do to ensure a safe touchdown for both the spacecraft and the booster? Let's explore. SpaceX's ambition to land Starship on a drone ship is crystal clear, especially with their decision to launch Starship from LC-39A. That's right, not just Falcon 9, but soon this iconic launch pad will witness the debut of the most powerful rocket ever built. SpaceX has already submitted a detailed operational plan to the FAA, which includes environmental impact assessments and landing options for both Starship and the Super Heavy booster. In this plan, SpaceX has proposed 3 landing scenarios for Starship. The first, and perhaps the most ambitious, is the Chopsticks landing. This concept is well known among SpaceX fans. The launch tower will use 2 massive arms to catch the rocket's 2 stages as they return to Earth. The second option is landing on a drone ship, a floating platform in the ocean. This method has become a SpaceX trademark with Falcon 9 boosters and promises flexibility in landing site selection. For Starship, landing on a drone ship allows SpaceX to easily position and recover the launch vehicle, especially during missions far from shore. The final option, known as a controlled soft landing, serves as a backup in case the other methods aren't feasible. This is a destructive scenario where the rocket is intentionally landed in the ocean and not recovered. SpaceX successfully tested a soft landing during Starship's 4th flight. Landing on the Mechazilla arms is a familiar concept and a must-achieve goal for SpaceX, but what about landing on a drone ship? This raises an intriguing question. How could Starship safely touch down on a flat surface? The answer lies in landing legs. In fact, landing legs aren't something new for Starship. They're already part of the human landing system version designed for moon missions and will be crucial for future variants built to land on Mars. These landing legs need to be robust and flexible enough to handle terrain far more rugged and unforgiving than Earth's surface. For the upper stage of this launch vehicle, landing on a drone ship is never an issue. Starship has variants specifically designed to tackle challenges far tougher than that. However, Super Heavy, the main booster of the Starship system, is designed with a different philosophy compared to the autonomous spaceport drone ships, ASDS, we're used to seeing with Falcon 9 missions. Instead, the Super Heavy booster is equipped with special mounting points on its body to facilitate the Chopstick system, a unique catch-and-land mechanism developed by SpaceX exclusively for the Starship system. The idea of Super Heavy having landing legs might sound strange at first, but in reality, it's a sensible strategy. The company has amassed a wealth of experience and valuable data from hundreds of successful Falcon 9 landings. Repurposing the proven landing leg design from Falcon 9 and scaling up this technology for the Super Heavy booster could save time, resources, and reduce risks during development. However, we can't overlook the significant size difference between Falcon 9 and Super Heavy. To illustrate this, let's look at some numbers. Falcon 9 stands at a total height of 70 meters, 230 feet, with a diameter of 3.7 meters, 12 feet. In comparison, Super Heavy alone towers at 71 meters, 233 feet, and has a diameter of 9 meters, 30 feet. This means the Super Heavy booster is taller than the entire Falcon 9 rocket and has a diameter 2.5 times larger. The landing legs of Super Heavy will have to endure much greater impact forces, suggesting a more robust structure and a more sophisticated shock absorption system. Moreover, controlling such a massive and heavy object during landing requires significant advancements in control systems and software. SpaceX will need to fine-tune their landing algorithms to handle the more complex dynamics of Super Heavy. One of the biggest challenges when landing a tall and slender booster is ensuring it remains upright and stable after touchdown. This challenge becomes even more complex when the rocket lands in strong winds or on an unstable surface. Currently, SpaceX's Falcon 9 uses a design with 4 landing legs symmetrically placed around the rocket. During launch, these legs are tucked along the rocket's body to minimize drag and protect them from the stress of flight. As the rocket prepares to land, the legs deploy, creating a wider landing footprint to distribute the weight and keep the rocket stable. While this design has proven effective for Falcon 9, a much larger and taller rocket like Super Heavy might require adjustments. The landing legs could be placed within the lower third of the first stage, or even lower, to help lower the rocket's center of gravity, much like how skyscrapers need a solid, heavy foundation to prevent toppling over in strong winds. But don't worry too much about this. Super Heavy already has a fairly low center of gravity thanks to the massive weight of its 33 Raptor engines clustered at the booster's base. The rest of the rocket's body, primarily fuel tanks, is generally uniform and much lighter than the engine cluster. This helps minimize concerns about the rocket becoming unstable due to a high center of gravity. Given the sheer size of the Super Heavy booster, the landing legs will also need to be designed to extend farther out than those on Falcon 9 to ensure the booster remains stable upon landing. This, in turn, means the drone ship must be significantly larger as well. A larger drone ship is essential to accommodate a rocket as massive as Super Heavy with its widespread landing legs, something unprecedented. Now, the landing leg design for the booster is bound to be something really interesting. Do you have any ideas other than a Falcon 9-like design? Comment below. It's important to note that the success rate of landing on a drone ship is hard to match with return-to-launch site, RTLS landings, where the landing pad is on solid ground, unaffected by ocean waves and other unpredictable sea conditions. The ocean's instability, with its constant motion, increases the risk of failure when landing on a drone ship. However, landing Starship on a drone ship offers a massive advantage: flexibility. These drone ships are mobile structures that can be positioned anywhere in the ocean as long as they don't interfere with other maritime operations. This allows SpaceX to select the most optimal landing sites for each specific mission, saving a significant amount of fuel compared to returning to the original launch site. Currently, SpaceX's drone ships are optimized for Falcon 9 landings, perfectly suited in terms of both size and launch frequency. In Florida, SpaceX's drone ships are typically supported by two recovery vessels named Bob and Doug. Bob and Doug don't just help tow the drone ships back to the recovery position, they also play a crucial role in retrieving the rocket's fairing. Because of this, they often have to be positioned slightly differently from the drone ship and can remain at sea for extended periods. As a result, SpaceX frequently has to hire additional tugboats to tow the drone ships to the recovery site and bring them back to port after the mission is complete. This process typically takes about 4 to 5 days to deploy a drone ship, recover the rocket, and return it to port, assuming there are no delays in the launch process. SpaceX has set its sights on an ambitious goal with Starship, aiming to launch thousands of these spacecraft each year. With a future full-stack Starship reaching a height of 150 meters, the current drone ships seem inadequate for recovering such massive launch vehicles. This suggests that SpaceX will likely need to expand its fleet by developing new, larger, and more powerful drone ships to meet this demand. Gwynne Shotwell, President and Chief Operating Officer of SpaceX, hinted at this during a press conference following her presentation at the FAA Commercial Space Transportation Conference on February 8, 2023. "We're going to have a lot of launch pads. I think we're going to have a lot of platforms at sea. We need to see how this vehicle is going to perform," she said. This statement suggests that SpaceX is keeping the door open for landing Starship on offshore platforms. However, for now, SpaceX is focused on testing and perfecting the RTLS capability for Starship. They are exploring the full potential of Starship to understand exactly what they need before deciding on the best approach for drone ship landings or offshore platforms. This is the foundation of Starship's point-to-point transportation capability, opening up a multitude of possibilities for global military and commercial plans. Notably, the U.S. Air Force has awarded SpaceX a $12 million contract to demonstrate point-to-point space transportation technology. This indicates that in the near future, we might witness Starship and Super Heavy boosters landing on advanced fortified military ships, ushering in a new era of global military transport. I also know that SpaceX has been actively considering expanding its space launch infrastructure to allied countries. It's not just about offshore platforms. SpaceX is reaching agreements to build launch pads in strategic partner nations, and they are actively working to make these agreements a reality. The first country outside the US to see a Starship presence could be Australia. If you're wondering why Australia, I've explained it in detail in a previous video, so feel free to check it out if you're interested. Whether it sounds outlandish or comes with its own set of technical challenges, SpaceX is set to land.